Okay, so welcome to today's video. Today is another security installment. Today we're going to be talking about this application called Mirth Connect by NextGen Healthcare. This has had quite a bit of attention on it in the past, June? About the past 9 months or so, there's been a lot of security issues and articles and videos and stuff surrounding this. And it was kind of funny because I've been meaning to do this demo for a little bit, and so I keep a list of packages that we want to create. I went ahead and created a package for this, by the way, just to show you. But I had like 3 different issues for it because it kept popping up as a problem. Why is it a problem? Well, if you look at this Horizon 3 article, basically it talks about a pre-auth RCE. Essentially you can just kind of upload some code and start going to town on this person's server who's ever running Mirth Connect. It really kind of comes down to a Java serialization issue. And so typically what this starts off with is like these process builders. Calls to this is just evil. But they note in this article, and I'll show you some other references, that after that was kind of dealt with, then they came down and they tried this InvokerTransformer, which is the same issue, but it's just dressed differently. Basically what this class does, and it's funny because this class even tells you that they're not going to support it anymore because it has so many potential security issues with it. And so, what Horizon did and what some of these others, which I'll show you, did was they were calling, get runtime and then chaining it on exec, which, basically does exactly what you think it does. It calls it, it spawns a new process. Of course, in Nanos, we don't have that. Now, I just want to be very clear before I show you the rest of the demo that even though Nanos protects against this sort of style of attack, there's other things that you can do with these serialization vulnerabilities to kind of get around it. So it doesn't like 100% protect against this class of vulnerabilities. What it does is make the potential problematic nature of these get toned down quite a bit. So this is more of a defense in depth defense versus kind of like a silver bullet. I just want to be super clear about that. But anyways, like this style attack with process builder and this InvokerTransformer, this stuff definitely neutralizes that. They show you a couple different ways, and they kind of walk through a different couple versions of Java. When I was throwing this together, I actually whipped up another Java version just so I could show you, because I'm using like 20.x and 22.x and all that stuff because it has all the cool new features, right? But I will show you that I was able to kind of repro what they're showing here and repro something else, and using the exact same Java version, like the exact same code running in Nanos, it prevented this. So let's go ahead and jump into it real quick. So we pop into here, and so this is Java 1.11 is the Java version I'm going to show you. Again, like I'm using Java 20.1 and stuff. You might be using something later too, especially if you're using Lim or something. But for this example, we're just showing 1.11. So we'll pop that open, right? And this is the same directory over here. I'm showing you what it looks like simply because I'm going to do something to kind of show you this issue. So we go to the other window, and this bob.py, let's see if I can, so what we're going to do here is, no, I don't want to open in Google Chrome. What the hell is this? So what we can do, and this is the example, this bob.py is what I pulled. This is kind of word for word. I didn't change the script at all. That's what we're gonna run here. We're just going after 8443, and then the command that we're gonna run is touch bob, basically just, you know, create a new file on the system. We're not supposed to be allowed to do this, especially not oft, when we're not oft. But we run it, and you see this. This is the payload that was shot. Again, you can see this get runtime, and you can see the touch bob, and where's the other one? Yeah. Anyways, so that's the payload that was sent. And if we go into this other directory, you can now see that, you know, our file was made. It really should not have been. Again, our server's running right here. So let's go ahead and kill this. Now I'll show you this CVE, this little script that I found on GitHub. You know, these exploits that you find on GitHub, this is, when I was growing up, this was like the very definition of script kiddie stuff. So, you know, this is pretty basic. It's the exact same code, by the way, except they've piped it into this POCs, and so I'll show you what that actually ends up doing here. So let's see here. Yeah, so CVE. All right, so what we're going to do is run this guy. Basically, it's that script that I yanked down. Again, I didn't make any changes to this. Same address, and these last two components, basically we're gonna open up reverse back here. So, you know, they got this little banner and crap. And so, yeah, so now it just dropped me in, right? And so we can do all sorts of random stuff here. You know, we can do local, and we can do all sorts of crazy stuff. In fact, we can say, what is it? Change local directory, and what was the, yeah, print local working directory. Well, that's my local. We it's active, yeah. Anyways, this gives us complete control over the system. We can spawn a shell, we can upload files, we can do all sorts of crazy stuff with it. Basically, yeah, that's what it does, right? Now let's switch back over to our actual unikernel version of this. Like I said, I took this Java, I created a brand new package out of it. So it's like the exact same thing. And this is our config. So this is what we're actually throwing into it. So actually, if you look at this config, this matches a lot of what is on Package Hub for the repo.ops.city. This has all the sort of settings that I included in the latest version. So basically all the directories, you know, our jar that we're running, obviously the args, and then I set a minimum size of 700 meg. I think the jar is like 600 something, and then it writes some, you know, temporary files. Obviously in a real life setting, you're gonna, you know, want gigs of disk or whatever. So that's the config. Let's see if we can find the command that we were using. One of these days I'll learn to type. So yeah, 1.11.0, our config, and then pop these two ports. So this takes a little second. Basically, keep in mind when we do ops package load, what we're really doing is we're building the disk image and running it at the same time. If you build your disk image with, say, ops image create, and then you do like an ops instance create, you'll see that the instance create is more or less immediate. right? But image crate, that's the part that you see that takes a little bit of time right there because we're actually literally copying over 700 megs. So now what we can do is we can do the same Bob deal. And so we do 1437. So the payload got sent, right? Well, let's just try out ops image ls Java. Okay, so we should have been able to touch Bob, right? But if we're looking at the file system, so that's what ops image ls actually is showing you right now. You'll see that that file was not created. So that's good news, right? Let's go ahead and run this other CVE. And you can see that it detects it and it says, hey, we found something that's vulnerable. Unfortunately, no shell for you because we quite literally can't run shells on unikernel systems. You could create like a web shell if you wanted to, but all the logic, like even something as simple as doing ls, you're going to have to code that into the Java class itself that you're going to be running. So we're not getting rid of this potential attack vector, but we heavily lessen the load, and we make an attacker send us a different type of payload that doesn't involve spawning new processes. So ran through a lot of this pretty quickly. Hopefully that's enough to go on. Till next time, catch you later.